In this video, we're going to talk about the graph of a specific equation in two variables, a line. Okay, so these are called linear equations. So a non-vertical, non-vertical lines are a bit special. So a non-vertical linear equation in two variables can be written as y equals mx plus b. You probably have heard that before. It's something that most people remember throughout their pre-calculus career. So a very important feature about these equations is that they have a slope. Okay, so what do we define the slope? Okay, so the slope of a line, okay, what it does is it represents its steepness. Okay, so steepness is what you should be thinking about there. So let me just draw you a little picture over here. Okay, so this is x and this is y. So imagine I have a line that goes like that. Okay, so there's my line. I can pick any 2 points on this line. So I don't know, let's say I pick one over here. Oops. Okay, so let's call that x1, y1. So it has coordinates, x1, y1. And maybe I have another point over here, x2, y2. Now it doesn't matter what points I pick. So if I wanted to talk about the steepness of this line, I want to talk about the difference in the y values and the difference in the x values. Okay, so essentially what I'm looking for is the ratio. Okay, so between these points. So here, I guess I would have x1 and x2, okay, and then the y values, y1 and y2. But this distance, so the change in the x values, this is called the run, and the change in the y values is called the rise. Okay, now the way we normally find these values, and actually maybe before I say that, I'm going to say the slope, which we often call m, is always rise over run. Okay, so to compute the rise, I want the difference in the y values. So the way I've drawn it, this one maybe is a bit obvious. So y2 is this whole height, and I want to get rid of this height down here, which is y1. So I'm going to do y2 minus y1. Okay, and it actually works the same way for the x's, even though one of my x's is negative. Okay, so this distance here is x2, and I want to add this little extra bit, x1. x1's negative, so if I do minus x1, it actually is a plus. Okay, so this is actually also x2 minus x1, and it turns out to always be that. So the rise is always y2 minus y1, and the run is always x2 minus x1. Okay, so this is what we want to remember when we're thinking about slope. So rise over run. Now, because these are non-vertical, you don't have x2 and x1 being the same thing. Okay, so you wouldn't have two y values for the same x value because it's not vertical. Okay, so obviously we don't want to divide by 0. Okay, so that is where the vertical lines come in. So it doesn't matter which 2 points you use. Okay, they all have the same ratio. So you can pick any 2 lines that you want. Okay, now there's some specific properties about the slope. So if the slope is positive, okay, then the line is increasing. Okay, so it goes up to the right. Okay, so if there's my axes, it's going to look like that. Okay, so you're going up to the right that way. If the slope is negative, okay, then the line is decreasing, which means that it goes down to the right. Okay, or up to the left if you prefer. The larger the absolute value of the slope is, the steeper the line. Okay, so a big negative number is also a steep line. Okay, so it means that the rise is much bigger than the run. So it's going to increase faster than it goes over. The b value is called the y-intercept, or the y value of the y-intercept. Okay, which means that the line crosses the y-axis at the point 0, b. Okay, so the y value is the b. When you cross the x-axis, or sorry, the y-axis, that means that x is 0. Okay, now, so this form is the most commonly used form, y equals mx plus b. We usually refer to that as slope-intercept form. So if it asks you to put your answer in slope-intercept form, then you're going to want to solve for y, so that it's in that form. Okay, so let's just do a couple of examples. So if I wanted to find the slope of the line passing through these 2 points, so 2, -1 and -5, 3. So I'm going to call this point the 1, so this is x1, y1, and this point can be the 2's, so x2, y2. So the slope, m, is going to be the so y2 minus y1, so 3 minus -1, over -5 minus 2. So that's going to give me 3 plus 1, so 4 over -7. Okay, now if you had done it the other way, x2, y2, x1, y1, it doesn't matter. Okay, the important part is that they line up. So if I did it this way, it would be -1 minus 3 over 2 minus -5. And here I get -4 over +7. Okay, but those are the same. So it doesn't matter what order you pick them. And I do want to just emphasize here, I'm going to go back up. So notice that the 2's are above each other and the 1's are above each other. Okay, so you want to remember y is on top, x is on the bottom, but then the points that match should be vertically aligned. Okay, so maybe that will help you remember. So it's fine. It doesn't matter what order you place what order you pick the points as, but once you pick them, the coordinates have to be vertically aligned. So you don't want to mix them up that way. Okay, so in example 2 here, we want to find the slope and the y-intercept of this line. So this is an equation for a line. It's not in a very nice form. Okay, y minus 6 equals -2 times x minus 1. Actually, it's in a form called point slope form, which we're going to talk about. So if I wanted to find the slope and or the y-intercept, okay, but the slope, what I can do is just manipulate this equation. Okay, so we could put it into slope-intercept form. Okay, so that's the idea. So to do that, all we have to do is solve for y. Okay, so we just want to rearrange this equation and solve for y. So the first thing I can do is expand that -2 through. Okay, so I'm going to have y minus 6 is equal to -2x plus 2. Okay, and now I can add 6 to both sides so that it moves to the right. And that gives me y equals -2x plus 8. Okay, so now we're in slope-intercept form. So now I can say that the slope, which we call m, is -2, and the y-intercept, or the b value, is +8. Okay, so if you want to find these things, sometimes just turning it into slope-intercept form is the way to go. Okay, so another form that we often use is called point-slope form. So sometimes when you're coming up with the equation of the line, you have the slope and a point that's not the y-intercept. Okay, so given a point x1, y1 on the line with slope m, okay, if we have x, y as another point on the line, then obviously this equation is satisfied. This is the slope of that line. Okay, now if I rearrange this equation, I could times by x minus 1 on both sides. So that gives me m times x minus x1 should be equal to y minus y1. So we can use this to find the equation of a line. So given the slope m, okay, so slope m and a point x1, y1, the equation in point slope form, I'm just going to rearrange it, but it's y minus y1 is equal to m times x minus x1. Okay, so this is the point slope form. Actually, maybe I don't like that. Okay, so this is the point slope form. And this is nice as a starting point for the equation. And sometimes if it wants it in slope-intercept form, then we can just rearrange it after. Okay, so that's the equation. Now I just want to make a note here. Okay, x1, y1, and m are constants. Okay, so we know these because we know the slope and the point. Okay, x and y are variables. Okay, so when you have the equation, you should have variables left in it. So the x and the y there are your variables. So you want to plug into the x1, the y1, and the m. Okay, so let's do an example. So if we have a line with slope of -4, okay, so that means that our m value is -4, and we know it passes through the point 3, -1, so x1, y1 is going to be 3, -1. And we want the equation of this line. We can use the point slope form, but they want us to give our answer in slope intercept form. Okay, so the point slope form gives us that our equation should be y minus -1, so minus y1, is m, so -4, times x minus x1, which is 3. Okay, so that's in point slope form. Now, what I want to do is simplify this to turn it into slope intercept form. So y minus -1, that's actually y plus 1. And then I can expand the -4 through. So I get -4x plus 12. And then I can subtract 1 from both sides. So that will give me y is equal to -4x plus 11 here. Okay, so now this is in slope-intercept form. So let me just write that. So here is, oops, slope-intercept form. Now you could actually do this another way without using the point slope form. So what you can do is say, well, I know that y is -4x plus b if I want the slope-intercept form, because I know m is 4. And then since 3, -1 is on the line, it must satisfy the equation. So that means if I plug in 3 for x and -1 for y, this equation should be true. So I can do that to solve for b. So y is -1, x is 3 plus b. Okay, so then I have -1 is equal to -12 plus b. I want to add 12 to both sides. So I get 11 equals b, which means that my equation, which you have to write at the end, is y equals -4x plus 11. Okay, and I notice we got the same thing. Okay, so either way is fine. You don't have to use the point slope form, but I find it's faster and it gives you the equation immediately, whereas here you have to solve for b but then give the equation again after. Okay, so there's that sort of extra step there. Oops. Okay, I'm going to leave this one for you to do later. So there's another form for a line. It's called the general form. So when you use the general form, okay, the form is ax plus by plus c, or equals c. And here a, b, and c are all integers, okay, if possible. Now this is the least useful form. Oops. Okay, so because you don't know the slope, you can't read anything from this line. Okay, so it's the least useful. So it's usually, the questions are often usually given like in this form, like this. Okay, but they almost never ask to leave in this form. Okay, so if they give it to you in this form and they ask for the slope or something about the line, it might be useful to turn it into slope-intercept form. Okay, so then you'd want to solve for y to do that. Okay, but I'm going to leave this example for you to do, and also that one. Okay, so vertical and horizontal lines are a bit special. Okay, so the horizontal line has what we say no slope. Okay, so what that means, i.e., is that the slope is actually 0. Okay, so the rise is 0. Okay, so the y values never change when the line is horizontal. Okay, and then there's a form, y equals b, so that's the constant y value. And this one is actually in slope-intercept form. So y equals b is the same as y equals 0 times x plus b, okay, where m is your 0. Okay, 0 times x, it means the x disappears. So you can write that one in slope-intercept form. There is a slope, it's just 0. Okay, when you have a vertical line, we say that the slope is infinite. It has an infinite slope. So that actually means that m is undefined. Okay, and this happens because the run is 0. Okay, so that's the denominator of the slope. So you can never divide by 0. So this one you cannot put into slope-intercept form because there is no slope. The slope is undefined. So the form here, this is sort of the only special one. So let me just highlight it. So vertical line has form x equals a. So that whatever the x value is. Let me just draw you a picture. So if you have a vertical line, okay, it's going to look like this. So if you take points on this line, okay, let's say this is at 2, okay, they all have x value 2, right? So we call this line x equals 2. Okay, so that's the idea. So let's do some examples, finding these. So find the equation of the line that passes through the points 1, 4, and 1, negative 3. Okay, so you might not notice anything's weird there. So we would just find the slope. Okay, so the m, so let's call this one x1, y1, and x2, y2. So you're going to have negative 3 minus 4 over 1 minus 1. So we get negative 7 over 0. Okay, now when you divide by 0, this is undefined. Okay, so when you get an undefined slope, that immediately tells you that the line is vertical. Okay, which means that the equation is just the x value. So it's going to be x equals 1 in this case. Okay, if you're not sure about that, just plot the points. Okay, so they give you 2 points. So I'd have a point x equals 1, y equals 4. So 1, and then 1, 2, 3, 4. So I get a point there. And then I'd have a point at negative 3, 1, negative 3. And then when you connect them, okay, you see that x is always 1 there. So that might help you come up with the equation. Okay, so now this one tells us it's a horizontal line. Okay, so horizontal, so this part here tells us that m equals 0. Okay, and it contains the point 2, 3. So you could use the point slope form. Okay, Or you could just realize that you're always going to have y value of 3. Okay, so maybe I'll just write point. Let's do it both ways here. Okay, so if you don't realize which value you should take, then you can use this form. So it's going to be y minus 3 equals 0 times x minus 2. Okay, 0 times anything is 0, so I get y minus 3 is 0, which means that y equals 3. Okay, and this is our equation. Okay, or you could have just realized that horizontal means that the y value doesn't change. Okay, so that means it's always going to be at y equals 3. Okay, which means that the equation is y equals 3. Okay, both of those are fine. Okay, so comparing lines. Sometimes we have two lines and they're related somehow. Okay, so if I have line L1 and line L2 and they have slopes M1 and M2, then we say that they're parallel if the slopes are the same. So if M1 equals M2, and we say they're perpendicular if one of them is the negative reciprocal of the other. Okay, so another way to say this, or if you multiply their slopes, you get -1. Okay, so that's another way to say it. So what you want to do, this is called the negative reciprocal. Okay, so what that means is you take one, you flip it, and you negate it. Okay, so let's do an example like that. So find the equation of a line perpendicular, let me just highlight that, perpendicular to the line 2x minus 7y equals 1 that also passes through this point. Okay, so what we're going to do first is take this equation here that they gave us, and we want to find the slope of that line. So I'm going to put it into slope-intercept form. Okay, so let's move the 2x over. So that means -7y is equal to -2x plus 1. And then we divide everything by -7 to cancel. So that means my y is going to be -2x over -7 is 2 over 7 times x. And this is going to be minus 1 over 7. Okay, so that means that the slope, I'm going to call this M1. Okay, the slope is 2 over 7. So that means that our slope, let's call it M2, is going to be negative reciprocal. So it ends up being -1 over the slope. Okay, but what happens is you flip the bottom one and multiply, you actually get -7 over 2. Okay, so you just flip it and negate it. And that's how we get our slope. Okay, so now for our line, okay, so the line we want has slope -7 over 2 and point -4, 3. So we can use the point slope form to say the equation should be y minus y1, so -3, is equal to -7 over 2 x minus -4. And we want it in slope-intercept form, so I want to simplify this. So I'm going to expand this through. So it's going to be -7 over 2x, and now this is actually a +4, right, with the negative, but then I times by -7 over 2, so it's going to be a negative, and it's going to be actually -14, because it's 28 over 2. Okay, now I want to add 3 to both sides to get rid of it. So then our equation is going to be y equals negative 7 over 2x minus 11. And this is in slope-intercept form. Okay, so you want to find a line perpendicular, you want to find the slope of the given line, and then flip and negate it. That gives you the slope of the perpendicular line, and then you just want to find the equation. Okay, so there's 2 more examples on the next page. I'm going to leave those for you to do, and they will be filled in a subsequent video. So that's what you need to know about lines at this point.